Okay, welcome to this video where we're going to look at finding the nth term of a quadratic sequence. Now I'm going to show you the standard method which is most widely used and appears in all the textbooks. Okay, and then in another video there's an alternative method that you might want to try. Okay, so the first thing we do is we're looking here at quadratic sequences, and these are sequences where the difference increases or decreases by the same amount each time. So let me just show you here what I mean. So in this case, the difference from one term to the next, you can see here is 3, and then it's 5, and then it's 7, and so on. And as long as it continues in a pattern like that, then it means it's a quadratic sequence. Okay, now what we notice now is what we call the second difference, which is the difference of the differences, and that should be a constant number. If it is, then we are dealing with a quadratic sequence, as we are in this case. Now we're just going to make a note of what the second difference is, okay? And in this case D is 2, okay? So I'm going to call it D for the second difference. Now what we do is we write the sequence, the first usually 5 or 6 numbers given, okay, and I'm calling that S. Now above it I've written N. Now N is the position of each of those numbers in the sequence. So when N is 1, we're talking about the first number, and N is 2, the second number, and so on. All right, and what we do now is we work out the sequence a half of the second difference times n squared. All right, and we just write that in here. So basically half the second difference is 1. Okay, so this is simply half of 2 times n squared, which is 1 times n squared. So 1 times 1 squared is 1. 1 times 2 squared is 4, and so on. 3 squared is 9, 4 squared is 16, 5 squared is 25, and 6 squared is 36. Okay, and what we now do is we subtract the sequence we've just written from our original sequence, and that should give us a linear sequence or a constant number. Now let's just see if it does. So 2 take away 1 is 1, 5 take away 4 is 1, 10 take away 9 is 1, 17 take away 16 is 1, and so on. And we can see that we have in this case just simply a row of ones. Now as I say, that row should always be either a constant number or an arithmetic sequence. Okay, now the final formula, the nth term formula for this particular sequence, is simply given by the quadratic part plus the linear part. This is what we call the linear part, or the bit left over. Now in this case it's really easy, because this sequence is simply defined as a half of d times n squared, so it's a half of 2, which is 1 n squared. Okay, and then we add on what's left over here, which is just 1. Okay, so this is the sequence, simply n squared plus 1. A very simple process in this case. Okay, and you can check quickly, because look, the first term is 1 squared plus 1. The second term is 2 squared plus 1. The third term is 3 squared plus 1. 4 squared plus 1 is 17, and so on. So it works. Okay, the second one a little bit more complicated. So I'll just change to a different color here. So the second one, okay, now we first of all work out D. Well, this is going up by 5. Then we're going up by 9. Then we're going up from 6 to 19, which is 13. Then we're going from 19 to 36, which is 17. And finally 36 to 57 is 21. And as you can see, the second difference is 4. Okay, So what we do here is we write down that d equals 4. Okay, and therefore half of the second difference is 2. And I've already written the sequence here to save a bit of time, so I'm just going to now work out 2 times the n squared. So 2 times 1 squared is 2. 2 times 2 squared is 8. 2 times 3 squared is 18. 2 lots of 4 squared is 32. 2 lots of 5 squared is 50. And 2 lots of 36, or sorry, 2 lots of 6 squared, 2 lots of 36 is 72. Okay, and now we do the same thing we did before. We do the sequence, our sequence, minus this sequence here. So minus 8 minus 2 is minus 10. Minus 3 minus 8 is minus 11. 6 minus 18 is minus 12. Okay, 19 minus 32 is minus 13. 36 minus 50 is minus 14. And 57 minus 72 is minus 15. So hopefully you can see there that we have a linear or arithmetic sequence. Okay, and again, if we didn't have that there, it means we would either have done something wrong or the original sequence was not quadratic. But clearly this is right. So what we do now is we work out the formula for this sequence here. So this is a linear sequence with a first term of negative 10, a second term of negative 11. So what's the 0th term? Well, the 0th term would be negative 9, okay, and the difference is, well, it's going down by 1 each time, so it's minus n, okay, minus 9. And the quadratic part is a half of 4, which is 2n squared. So the sequence has a rule 2n squared minus n minus 9. And that's the nth term rule for our second sequence. Okay, now finally we take the third sequence. All right, and this one a little bit more complicated. So let's have a look at what we have here. So we have 23 to 20. Well, that's obviously a drop of 3, so we put minus 3 there. Then we go 20 to 13 is minus 7. 13 to 2 is minus 11. And 2 to minus 13 is actually minus 15. And finally we have a minus 19 there. So you can see that this is going down. The second difference is negative 4. Okay, negative 4, but it's the same each time, so that means that we do have a quadratic sequence. I'm just going to write here that d equals negative 4. Okay, so I'm just going to partition that bit off because that belongs really to the previous question. So if I just take this off here and down here, okay, because that part there belongs to the previous question. Okay, right, going back to this then. So d equals negative 4. So that means that I have to do half of negative 4, which is negative 2 times n squared. So this becomes negative 2, negative 8, negative 18, okay, negative 32, negative 50, and finally negative 72. Okay, I've basically taken these numbers from this question and just put the minus signs in front of them. All right, because that's negative 2n squared. Do the same thing, subtract that, take away that. 23 take away minus 2 is 25. Okay, 20 take away minus 8 is 20 plus 8, which is 28. 13 take away minus 18 is 13 plus 18, which is 31, and so on. This one comes to 34, this does come to 37, and finally, negative 32 take away negative 72 is negative 32 plus 72, which is of course 40. So here we have a linear sequence or an arithmetic sequence going up by threes. What would be the 0th term? Well, it would be whatever would appear before the first term, which would be 22 if you went back 3. So the formula for this one is 3n, okay, 3n plus 3n, and it's 22 plus 3n plus 22. Okay, and what we now do is we take the quadratic part, which is a half of minus 4, which is minus 2, so it's minus 2, I'll just write it here, minus 2n squared, okay, plus 3n, okay, plus 22. And that would be the nth term rule for this third sequence. Okay, now we can just quickly test it just to make sure it's working, and you should see that it does. So let's find out. Well, if we just try it for 1, let's just check that that does give us 23. Okay, so we've got minus 2 times 1 squared, that's minus 2, plus 3 ones are 3, so it's minus 2 plus 3, that's 1, plus 22 does indeed make 23. Let's just try it for another number here. Let's try it for 5 and see if we get negative 13. Okay, well, 5 squared is 25. Okay, so negative 2 times 25 is negative 50, plus 3 5s are 15. Okay, so that's negative 50 plus 15, that's negative 35. And if you then add 22 onto that, you do indeed get to negative 13. So it certainly works for that, and it certainly works for 1. So you can be sure it will work for all of the numbers and any number beyond that. So if you wanted to find the 20th term of this sequence, all you'd need to do is replace the n in here with the number 20 and work it out. Okay, there is another method. It's in another video. I hope this has been helpful. Take care.